Good morning, Professor.
Hi, Karen, you and I.
Well,
Hey, what happened to your test? You didn't get a very good grade, huh?
I don't know why.
So what was it? Was it difficult? You just didn't have time to?
It was a little more difficult, this quiz, and I did have time to do it. I don't know why I didn't do well, but it's okay.
Hey, I don't think you need to worry because you're doing well to begin with.
Okay, thank you.
So how are you doing in your other classes?
Doing good. Just getting through it, but not bad. I'm doing pretty well, so that's good.
Do you still have to take a bunch of them in the spring, or are you done?
I just have student teaching in the spring, and then I'm done.
Oh, because you are in educational major as
Yeah,
well as
I'm
psych.
doing a
I
double
see.
major, so
Ah, oh,
almost done.
nice.
Thank you.
This
Almost
is
done.
good.
Yeah,
I mean, they keep saying that a lot of colleges and universities are closing their education programs.
yeah,
People don't want to go into teaching.
yeah. I know.
So
It's very
so
strange.
strange. That's where we need. Yeah. Hi, Ari. That's where we need, right? Most of the
Exactly.
efforts. I mean, we all see that when students come to us, and it's like, what do you do?
What are you gonna do?
All right.
I'm deviating away from it a little bit, but
In which way?
I don't know. I'm going into the psychology field a little bit more, clinical psychology, so I'm probably not going to be a teacher for much longer. but we'll see.
Hmm.
Yeah.
Well, you could do school psychology.
Yeah, I'm applying
You
to
know.
school and clinical psychology programs. So that's the ultimate goal.
Hmm. Okay. What about you, Ari? When are you graduating? Oh, you're just a freshman. Oh, a long haul. You're gonna get the best of the online college, huh? Oh, physical therapy. Yeah, that's good. That's good. It's a professional field. Anything that has to do with health is healthy. It means there are good prospects for jobs. So it's a good thing. All right, you guys, let me ask you. I assume that you are fine, but just to make sure. Ari, did you do the experiment 3? Did you collect your data? Yes, you did. Uh huh. Karen, I assume you did that too, right? Okay, good. And I know Leroy did. He told me last time. All right, so let's get going. Where are we? Hi, Leroy. How are you?
Good morning.
Yeah. Oh, you look good. Okay. All right. Thank you guys for joining me. I'm not that lonely with a few of you. Okay. Again, because it's going to be recorded, hopefully some of your classmates will see that. Just to remind you that today is the deadline for data collection. Out of 19 people currently in class, 16 have done so, but there are 3 people, and I don't know who they are until I close the experiment, which I don't want to do because then I'll have to reopen the new session, which again, I also don't want to do. So please, 3 of you, talk to your group mates. If they haven't done so, please encourage them to do it today. All right. Thursday is going to be an opportunity for you to do another participation point if you would like to do so. It's going to be that postponed CSI psychology colloquium applying to grad school at 2:30 during club hours on Zoom. The announcement is posted on the Blackboard. So, Karen, you definitely should attend it. It always helps to go to as many of these things as possible. Right. Now, this Thursday, can you imagine it's going to be the last class we can work on your lab 3? Because next Thursday is Thanksgiving, and then Thursday after December 3rd, that's when the lab report is due. So what I'm asking you to do to make sure that our time is productive is that you should read the research article for lab 3. Just to remind you again that I'm not asking you to read the whole thing. It's relatively complex. I'm asking you to focus on introduction, study 1 or experiment 1. I don't know. I don't remember what they call it. Then skip experiment 2 and do general discussion. And as you read this article, you should ignore everything and anything where the authors talk about non-words. We are not going to be looking at that at all. We will only look at the conditions where both letter strings are words. Okay, so please come prepared to discuss the article. The usual questions that I would want you to know, such as the design, independent and dependent variables, materials, potential examples, most important, the results, because you'll need that for the second paragraph of the introduction. And the last thing that we will need for Thursday is for you guys to be familiar with your Lab 2 report and the rubric that I sent you. This time, to make life a little easier, I actually filled it out uh, not as a, the number and the score, but the actual rubric. So we will try to work on Lab 3. Like I said, this is the last chance. Looking at your Lab 2 so that you don't repeat the same errors that you did. Almost every single group, and maybe there's one exception, has improved from Lab 1 to Lab 2. So for Lab 3, the goal is to improve even further, beyond. Leroy, I expect you to get an A this time. There is no excuse because you can do it. Um, in terms of data analysis, it's going to be exactly the same as the first two. It's paired samples t-test. We'll talk a little bit about the figure and how to write the results appropriately in the APA format. Again, so have your, all right, that's our next slide, so let's do that. All your work should be done in your group Google Doc, because that's the only way that we can see the contribution of each partner. In case there are any disputes about who contributed what, who was the leader, this document will give us the history of your participation. So I'm asking you to continue to do all the work in your group Google Doc. And when you're ready, that is December 2nd or uh, early in the morning on December 3rd, is to download it into either Word or Windows and then convert it to PDF if you wish and submit. So that the entire lab report, including all the changes and modifications and the stuff we will do on Thursday, should be in that document. Okay. So when you come on Thursday, have your Google Doc open and have your Lab 2 and rubric ready so we can be as productive as we can. All right. The last logistic thing is this is it. This is what's left. So we are doing concepts and knowledge this week, except we're not really doing it on Thursday because we'll be working on Lab 3. Next week is half a week, so we'll do our usual lecture on Tuesday, the 24th. It's going to be problem solving chapter 11. It's kind of fun, mm, not as perhaps abstract as concepts and knowledge, which is today. We will probably be just doing it for that Tuesday. Maybe I'll have to see how far we can get. Maybe I'll take another half hour or so on Tuesday, December 1st to finish problem solving. As always, your quiz 11 is due on Monday by 10 p.m. Now remember that you get only 10 grades out of 12. So if you're happy with your current 10 grades, you don't have to do the remaining two quizzes. If you want to improve, or if you missed one, then you should. And then there will be quiz 11 for chapter 12. And I think we may not get through the whole thing anyway, but we'll see. All right, December 8th is our last. So December 3rd is your Lab 3 report due. I most likely will grade it relatively quick without necessarily filling out the rubric, but reading through it. We'll see. And December 8th is going to be our last class. We'll finish whatever we have to finish. And we can talk about life. Like Ari is still a freshman and Karen is graduating. That's exciting. People are doing different things. And then presumably 8, 10, yeah, by the end of that week, which is going to be I'm calculating the 13th of December, 14th of December, I will have your grades. So, because all I have to do is grade lab 3. Okay. Um, yeah, in terms of your blogs, I've been keeping up with them, but I encourage you to double check, because remember, if you were answering the questions based on reading the articles, that's worth 2 points. I hoped I didn't miss any of those. Everything else is 1 point. 1 point. In the beginning, I was a bit more strict. If you didn't do right, you did not earn the full point. But at this point, I'm not doing that. So as long as you submit something and it's 200 words or more, that is, you've put in some efforts, you should be okay. So double check your blog entries and see if whatever reason I could have missed something, and I'll be happy to do so. Oh, and the final thing that I sent a message to the class. If anybody is interested in doing a pilot experiment that's being conducted, obviously it's a cognitive psychology experiment, actually, language-based experiment, that is being run online by my colleagues at McMaster University in Canada. This experiment is actually quite exciting. It's interesting. It's long though. It takes, depending on how fast you can read, 70 to 90 minutes. That is an hour to an hour and a half. So if you are interested in participating in this experiment, we are looking for a few people who would be the first ones at CSI to try it, because it's going to go on Sona for Psych 100 students. We just want to make sure that it works well, that there are no glitches. So if you are interested in doing that, I will give you 4 points for doing that, regardless of the results. I'm not going to see them. They will go directly to McMaster. What I will see is just whether you participated or not, and you should do that. So if you're interested in doing that, we would like to have people do it this week. So if you're interested, email me and say, yes, I would like to do that McMaster pilot, and I'll send you the link. You'll participate, you'll contribute to data, you'll tell us if there were any issues in terms of the progression of the tasks. There is a bunch of small tasks and one slightly larger task that has to do with reading comprehension. If you ever wanted to know how good you are understanding the text, here's your chance. Good. That's all I have for logistics. Unless you guys have any questions, you can ask me at any point. Let's move on to chapter 10, concept and knowledge. Now, the good thing or the interesting thing is that this is a little bit of an overview. I will mostly focus on traditional or classical view of categorization, that is Aristotelian, the way we classify objects as proper sets. I will try to get to the prototype theory. I definitely don't think I'll get to the exemplar theory, but these two actually I described pretty well in the textbook, so I'm less concerned if I don't get to them. Now, the exciting part is that this is our last component in studying cognition. We started at a very low level, well, very. We started on sensation perception, which is at the border with the real world. And after that, cognition starts in earnest. And we started with, again, sensation and distal and proximal stimuli that are important. And we talked about, and we continue to talk about, the fact that modern cognitive psychology, as well as cognitive neuroscience, are based on two very important concepts. One of them is mental representations. When we perceive an object, what we construct is a percept, and a percept is a mental representation of that object. We also talked about imagery. That means that our mental representations often behave just like real percepts. The second most important feature, so to speak, of current cognitive psychology, neuroscience, is the information processing approach. That is, we talk about stores in memory and the way they are connected, like a three-stage approach: uh, acquisition, storage, and retrieval. Um, so we move from perception into attention, which is a filter, at least in some theories, between perception and memory. And there was language, and language is critical because it sort of permeates the entire cognition from bottom to top. And now we are approaching, well, we have approached the top. And the top is thinking. And thinking is what really distinguishes our species from the rest of the animal kingdom. That's why we are spending the last 3 chapters on that. And if we think about how the processes that we started with, learning, we didn't talk much about learning, but we talked about classical conditioning as an example. We spent a good week on perception, and now we are moving to thinking. And that the idea is that none of these two processes, learning or perception, and then memory, which I'll come to in a minute, are possible without thinking. Because in classical conditioning, you learn to connect two events, one that's occurring naturally, right? The other one, sort of unconditioned stimuli, and the other one that occurs with this one and becomes a conditioned stimulus. And you learn to predict from them, first from the unconditioned stimulus and then from the conditioned stimulus, what will happen. And to do that, you have to think. And the same applies to instrumental conditioning. We didn't talk about that, but the difference is that in instrumental conditioning, our participant, an animal or a human, actually learn to control the event, that they control the event and things happen, good things or bad things. Again, you need thinking. Thinking maybe in a form of problem solving, because what's going to happen in today's chapters and in chapters 11 and 12 is problem solving, reasoning, and judgment. All of that are examples of thinking. For perception, we need that too. Once you have your percept, right, you need to know what that is, where it is, when it happened, what it can do to you. All of that requires thinking. So our lower level of cognition sort of organically lead us to thinking, which is the last 3 chapters of the textbook. There's actually more, for example, consciousness, but we don't have time for that. We actually have a course on the books, and I should think about teaching it, called phenomenological psychology. But again, there's too many others to deal with. All right, memory obviously is also critical because it supports thinking. Think about the distinction that we talked about in the long-term memory chapter. We have episodic memory, which has to do with specific events that happened to you at a particular time space. Could be, for example, biographical memory. And the other component is a semantic memory, which is facts and beliefs and attitudes and things you know, like grass is green and Columbus discovered America or whatever else, making it the core of our knowledge. Again, and that's about thinking. So the the crux of this chapter is what is knowledge and how it is represented in the mind. There is a subsection at the end on categorization in the brain. I won't have anything to say about that because I know we'll not get to that. But if you take 232, physiopsychology, you will be doing a lot of brain representations. All right, so for us, it is the mind. For cognitive neuroscientists, it is the brain. But of course, they are two sides of the same coin. All right, so categorization. Like I already said, this is a fundamental cognitive process because it's already at the top of our cognitive abilities. Here is a couple of definitions. We have to partition the world. We are not just perceiving it and thinking about it or creating memories about it in sort of indistinguished way. We have what we call categories and concepts. Now, these two things are slightly different. So think of categories as the actual objects in the world. So you have a tree, that's a category. Let's say it's an oak, that's a subordinate level of a basic category tree. And concept is the mental representation of that object. So think about the object in the world and its percept, your particular event in the memory, and engram, the memory trace. The same idea. You have a category and you have a concept, its mental representation. However, in the textbook as well as in general, psychologists don't always uh, talk about it in this sort of strict division between the category and concept. In fact, use them interchangeably, and so will I, just because as long as you understand that anything we do in cognitive psychology is inferential, that is, there is no direct way of observing cognition, we always infer. The same is here. Okay, so think of that as a sort of applied definition is our ability to classify objects. So looking at something and saying, oh, that's a dog, or looking at something and saying, oh, that's a fish. Okay? So we are trying to impose some kind of a hierarchy on our world by taking a bunch of objects, a bunch of categories, and saying they are the same, they are similar in certain ways, and we will call those attributes or features. And therefore we'll group them together. And we do it all of the time. Babies do it. Toddlers do it. Little children do it. L2 speakers do it. Everybody is doing it. This is such a fundamental cognitive process. And that's why we have a whole chapter dedicated to it. Okay, so how do we do that? I already used the word features and attributes. Now here's the word properties. All of those are synonyms. Again, terminology, as is the case in many other sciences, is a little wobbly. We have a bunch of synonyms. So we say that it's a category in a categorical class, right? When we have objects that have some properties, attributes, or features that are common to them. In fact, Jerome Bruner, the psychologist who lived to be 100 years old, we talked about during perception, who was a proponent of the constructivist view of perception, said that every act of perception is an act of categorization. So if you're looking at something out there, you are categorizing that thing because you need to know. Remember, the example is if you see a gorilla, well, you need to know the gorillas are dangerous. So you classify it as a dangerous animal from which you have to flee. Okay? And of course, it has to be based on your memory of seeing gorillas before or reading about them or knowing that gorillas are wild. The perception, memory, and thinking all come together. All right, I already said that. So now I will talk about the category as a class of objects, maybe people, maybe things, maybe entities, in a sort of intuitive way that we all will agree that a bunch of these objects belong together because they have similar properties. They look the same, or they look similar, not the same. Again, the same is not the right word. And that's what will give us categories. And of course, they will have different kinds of representations and memory. So again, I'm just trying to bring together perception, memory, and thinking. Just to remind you why it is important, because when you impose classes or classifications on the object in the world, on the objects in the world, you make the world simpler. You are reducing complexity. All you need to know is there is a category of dangerous animals. You don't care whether it's a gorilla, an alligator, or something else. It also helps us identify new objects. If we see a new animal, we are more likely to be able to classify it, right? And it also allows us to act upon that, just like knowing perceptually what the percept is helps us do things. All right, so this is our little introduction to the way of thinking. Again, thinking will include categorization, problem solving, judgments, and reasoning with other processes that are not described in the textbook just because there is no enough space for it. And the main sort of uh, way of thinking about categories will be this representation. We'll talk about basic categories, sometimes called something else, and the two types of hierarchical relationships between them and what's above them hierarchically and what's below them. So the basic level here will be chair, table, bed, car, truck, bicycle. And then what goes above is superordinate category. And the way we get to superordinate category is by listing all the properties, or features, or attributes of the basic level and then subtracting a bunch of those, giving us fewer properties and allowing us to move forward. So there is something common between cars and trucks and bicycles that makes them vehicles. There is something similar about chairs, tables, and beds that make them furniture, but you're losing properties on the way up. Obviously, going down, we have subordinate level of categories where we add properties. So if we have a car as a basic level, then the subordinate will be Ford or Chevy, and we know we have to add a few more, at least we could say it was made by Ford, right? We will have to add properties when we go down, when we go to subordinate level. So basic level gives us the proper set. Going above to superordinate requires us to subtract features that are not common at the top, and going down requires us to add features or properties. So keep that in mind because that will continue to come back throughout all the three theories that are described in the textbook. So we'll start with the classical approach to categorization. That's categorization through definitions. Like I said, that's the smallest, not enough of information on 2 pages in the textbook. That's why I want to spend a little bit more time on that. While the other two, the prototype approach and exemplar approach, uh, are described much better in the textbook. I didn't put the name for exemplar approach because there isn't really one person that is sort of representative for the exemplar approach, Medine perhaps, but for the prototype approach, Eleanor Roche with her work in mid-70s is the founding mother, so to speak, of that. But classical comes from Aristotle and goes all the way to Ludwig Wittgenstein, a philosopher that is described in the textbook, whose work is described in the textbook. All right, so let's start with the classical approach. So categorization by definition. This is how it works. So Aristotle is the guy in the red coat on the left, red cloak, I guess it is, on the left. And this is from the Vatican fresco um, in Rome. So he wrote a book called Categories. And there's many other things that we actually learned about in this class. His theory continues to be influential, although there are many problems with it, as we will discover a little bit later. So we talked about the 5 senses. This is also Aristotle. So a very important thinker, philosopher, and scientist in the history of mankind. So his idea is that humans are rational thinkers. What do we mean by rational? That is, we are guarded by logic in our behavior. In this case, we're interested in categorization behavior, right? So we are thinking logically when we categorize. And he used the word called well, not the word, the phrase called proper sets. So he says, categories are proper sets. What do we mean by proper sets? Well, set obviously is a bunch of things, right? More than one. So set in this case refers to properties. Again, let me reiterate that this word has multiple synonyms. Attributes and features are the most common ones. And proper means that all categories can be described in terms of those defining features. So defining features are the ones that make proper sets. So if you're looking at these two men, well, you know they're men because you can come up with defining features. Well, they have to be human, right? They have to be male, right? Um, and they probably have to be grown up. So if a child, 2 or 3 year old boy, is that a man? Probably not, right? So these three features will be defining features. You have to be human, you have to be male, biologically, whatever, and you have to be a grown up. So if you take these three features, this will give us a proper set of men, a category of men. The features in Aristotelian classification have to be what he calls singly necessary and jointly sufficient. Okay, let's talk about that for a second. What do we mean by singly necessary? What do we mean by jointly sufficient? So if you have features that meet these two criteria, you have a proper set, and therefore you can define your category. Okay, so what do we mean by singly necessary? That means every single member of this category has this feature. So again, the example I just worked with was men. Every one of them is human. Every one of them is male. Every one of them is a grown-up. Okay, so you have to, there are no members of the category that don't meet one of these three requirements, so to speak. So if there is a woman there, well, she is not male, therefore she cannot be a member of that category. Now, the next one is jointly sufficient. So every member of the category has all these features, and therefore it becomes the member of that category. Okay, so if one of these features is missing, then this object cannot be a member of the category. So again, if it were a woman, missing a particular feature of maleness would disqualify her from being a member of that category. So it looks very logical. It should work. At least that's how Aristotle thought about it. Okay, let's look at some of the examples. The best examples come from mathematics and science. So let's think about geometry. Hope you guys remember your high school geometry. Okay. Let's talk about triangles for a second. Well, how do we define a triangle? So what are the singly necessary and jointly sufficient features? Well, they have to be two-dimensional. That's what planes are. They have to have three sides and they have to have three angles. Now, then every single member of that category will be a triangle. If we want to define quadrilaterals, again, they're two-dimensional because that's what planes are, but they have four sides and four angles. And that makes it a quadrilateral. Now, of course, there are subordinate categories that we're not talking about yet. If you think about animal kingdom, here is our scientific definitions for birds. They're vertebrates, warm-blooded, and they have wings and feathers. Fish, on the other hand, are cold-blooded, but also vertebrate, and they have scales and fins. So having these four features will define every single member of the category fish. But not having one of them should disqualify you for being a member of this category. So singly necessary versus jointly sufficient. Okay, so let's look again at the geometric figures in more detail because it's just the easiest one. All right, this is what I just mentioned, 2 dimensions, 3 sides, 3 angles, and all triangles will have these 3 defining features in common. So if you were to give a definition of category triangles, that's what you will do. You'll use these 3 properties, giving us a proper set. Okay. Again, they're singly necessary, and the entire set is jointly sufficient. That is, you have to have all these 3 to define the category of triangles. Because if you take 2 dimensions, then you either get 1 dimension of 3 dimensions. In either case, it's not going to be a triangle. If it's a 3-dimensional, it's going to be a conical object, I guess. If you take the angles away, if you have 4 angles, then it's not a triangle anymore. It's a quadrilateral. The same applies to sides. You see how it works? So in the realm of mathematics and science, proper sets really work beautifully. But of course, we have other categories that we'll talk more about a little bit later. So we have categories that come from the natural world. Think about, I don't know, trees or flowers or events like holidays. These are all categories, right? We can have logical categories. We don't need to even think about them. We can have functional or goal-oriented categories that have to do with the way we function in this world, not necessarily mathematical or scientific sets. We'll do a little bit of a example soon. So here is our first category. It's very broad. Things. So what are the features, the singly necessary and jointly sufficient? Well, we could say these are objects, either created by Mother Nature or created by us. So which of you guys can give me a few members of this category? So I only gave you basically 2 features, created by humans or created by Mother Nature / God, whatever your approach is. Who can give me a few members of this category?
Animals.
Okay, trees, grass. Yeah, so these are the farms created by humans. Good, perfect. That was easy. Let's try something. Oops, let's come back. Let's try the category of actions. So what are the singly necessary and jointly sufficient properties? Well, it has to be some kind of a change of state, right? So there was an initial state, something was done, and now there is a different resulting state. Again, because it's a very abstract category, it's a little abstract. Okay, who can give me a bunch of members of this category? What are actions in our life? Run, okay, movement of anything, yeah, maybe, moving would work well. So running, moving, mental actions as well. Cleaning, okay. Thinking, right? All of those. Perfect. Good. Speaking, yeah, definitely. Events, okay. Well, events, we can think of a bunch of properties or defining features. They have a beginning and the end. They have a set of props, right? And a set of participants. So these will be the defining features. Weddings, yep, excellent. Parties, good. None of those that we should be engaged in. What's coming? Election, yes. What's coming our way next Thursday? Life. Well, getting together as a family, right? Thanksgiving, yes. And the idea is that this should not be an event anymore this year. Okay, good, good guys. You follow the defining features story. Abstract categories. So these are categories that are kind of difficult to define exactly in features, but we say that they're not like objects, so we can define them as a negation of something. But they are relevant for our cultural life and maybe our consciousness. Yeah, okay. Things that abstract things that happen in life. For example, justice, right? Peace, all of those, right, will be members of this category. How about this one? Complex systems. In this case, what would be the defining features? Well, it's complex systems that were created by humans for humans, perhaps. That's one possibility. Feudalism, right. A type of historical epoch. Right. But something more contemporary. Education, right? We have an educational system where we take children from pre-K into K to elementary school and junior high school, perhaps graduate school, right? Any other examples of complex systems? The human brain. Yes, it doesn't follow my definition. My definition was something created by humans for humans. So obviously, the brain was not created by us. So we could say that there are natural complex systems. The human brain, or the solar system, or the universe. Mhm. Excellent. So you see how those defining features work. They work pretty well in examples like this. So let's quickly summarize that. Categories as proper sets. So that's the classical view by Aristotle. I always identified by their defining features, right, of two types. That is, we think of the features as singly necessary, jointly sufficient. Okay. And they can be arranged vertically. I already started talking to you about basic versus subordinate and superordinate levels. Okay. They can also be arranged horizontally. That is, if you are a member of the same category, you are neighbors. And there is another thing called homogeneity. And we'll talk about it in a minute. Homogeneity means that all the members of the category are good examples of that category. Doesn't matter which one you are. So let's talk about properties. Well, not properties, but sort of conceptual representation of 2, 3, and 4. So let's start with vertical arrangement. Again, I'm going back to uh, Pythagoras. That's the geometric figures. In that system, the first level of classification is number of dimensions. So no dimensions are periods, dots like this, right? One dimension, one dimensional are lines, it's just this. Then we have planes. Planes have 2 dimensions, so this way and this way. And the fourth one is 3-dimensional. Now we understand that there is height, width, and depth. So that's the first level of classification. Now if we select quadrilaterals, they are planes, right? These are planes. 3-dimensional guys are here. And planes for quadrilaterals are defined as having, for example, here 4 sides and 4 angles. If we take a plane that has 3 sides and 3 angles, we're going to get a triangle. 5 penta, right? We're going to have 5 sides, 5 angles, right? So this is like technically a basic level. You can think of that as a basic level. And we can continue. So this is a vertical hierarchy, right? We start somewhere. These are figures. Then we go to the level of dimension, none, 1, 2, 3. Then we go to the level of number of sides and angles, 3, 4, 5, 6. So we're going down, and we can say, because it's jointly sufficient, this, let's get something, this object, okay, is hierarchically under planes because it's 2-dimensional, right? And that's a member of geometric figures. And we could go down by saying that there are different types of triangles, right? So that's the hierarchical organization. It's nicely demonstrated in math and science again. Okay, so think of that as an explanation that I just showed you. And this is how we would go down from triangles. There are at least 3 types that we know when it comes to sides and angles. And we have equilateral triangles where all the sides and all the angles are the same. We have scalene, isosceles. So these are different sides, different angles. And again, we have the same idea that, let's say, scalene triangle is going to be a triangle. So because it has the 3 defining features, right? It's a plane, it has 3 sides and 3 angles, right? That gives us a very easy classification algorithm. So if somebody shows you something like this, or something like this, in both cases, you will be very confident in saying, hey, these are triangles, because these 2 objects meet the 3 defining features. Okay, so vertical arrangement, we have subsets, subordinate categories. To do this, we have to add a feature. So for the isosceles, scalene, whatever I was using, triangle, we say, okay, the 3 defining features of all triangles are planes, 3 sides, 3 angles. Now let's add one more feature that has to do with the angle, right? Giving us an additional feature. If we want to move away from triangles into the planes, we have to take away the sides and angles and just keep the dimension level. Okay, so we are subtracting defining features. Again, a very nice way of classifying when it's doable. And you should start thinking, is that really the case? Can we always do that? Here is one of the activities for you if you would like to play with the vertical organization of a particular category. Do activity 12.2 for today's week. Activity 12.1 has to do with the research article for Lab 3, Meyer and Schranewald's lexical decision, which obviously you should do because you will need that for your lab report. Another example here is from Roche. Now using her terminology, basic level category. Here's table, right? Can somebody give me the defining features for tables? What makes a table a table? Four legs. Yep. Good. That's feature number one. Okay. Nor, yes. Four legs. What else? We have to have the full set of features. Just four legs is not good enough. Chairs also have four legs. Flat surface. Okay. Held by four legs. Good. Now that's two defining features. Also not enough. You can imagine something like, well, I'm trying to figure out like a pergola, tall four legs and flat surface, which is not necessarily solid and not necessarily at the level for humans, right? So we would need additional defining features to make a table a table. Perhaps it's an attribute that has to do with the functioning of that object. We use it for putting stuff on it and being able to, I don't know, use the stuff on it. All right. So now we are going to add features. So what's a kitchen table? Well, additional feature would be it is housed in the kitchen. So it is going to be the three defining features that we sort of identified, plus one more. And we think of kitchen tables as something that we use in the kitchen. And if we want to go up to superordinate level, now we have to lose features. Okay, so we will lose legs most likely, because we can have couches that don't have legs. We will have to lose surface, right? And what's left is sort of functioning as furniture. All right, so that was my subordinate and superordinate things again. Okay, well, if you think of that as sort of an applied example, anything that is more generic is going to be superordinate. Anything that is more specific is going to be subordinate. And the basic is the sort of the intuitive one. It's the one where somebody says, well, give me an example of furniture. You're not going to say furniture. You're going to say chair, table, bed. So this is what is the core of the category. The problem is that in the Aristotelian view, there is no core. Every single member of that category is as good as any other member. So I'm sort of running ahead of us because that's going to be the prototype approach by saying not all members of the category are equally good. And if you have to be more general, Noor, you will say, well, things that have four legs and surfaces, they're all a furniture. And that's going to be superordinate. You're losing the features of legs and surfaces. And if you want to be more specific, let's say instead of kitchen table, I could say a desk, right? A desk is a type of table. So here you need to add another feature, which will tell us that you are using the table for work, for writing or typing, or whatever. Okay? So as long as you can identify the basic level, you can figure out superordinate above it and subordinate below it. So global versus specific, that's how Roche talked about it in the beginning. Okay, confused about it. I was a little confused. Yeah, the best thing, Noor, is to go through examples. That helps a lot. As long as you understand the notion of defining features and you understand how you lose some features or add some features, you should be able to see the difference between the three levels. But again, going through examples, we'll do a few little exercises to help you solidify that. Okay, so that was the vertical organization of categories. Now let's talk about horizontal ones. So if we're looking at tables, right, and other members of the category furniture will have tables, chairs, beds, wardrobes, credenzas, I don't know, anything else, right? These are all siblings, right? They are at the same level. They are members of that category. And the point here is that you cannot be sort of halfway into category. You're either in or not. And we'll get to some examples in a minute. I'm encouraging you to continue to think about furniture as a category, and I already mentioned a few of those. Can you imagine a member of the category furniture that's not that good? And you would even say, I'm not sure whether this is furniture. No, Parker, a broken chair is a broken chair. It's still a chair. We can easily say, look, it has four legs, maybe one of them is broken. It has the flat surface you used to sit on. It may have a back. It's still a chair. But I'm asking you to imagine a member of a dubious member of the furniture category that you would say, I don't know. Remember that another feature that we didn't include in the beginning was that it functions. Vase. mm. Well, I think Leroy vase might be a problem because it doesn't have the same function as tables and chairs and desks. It needs to be able to sort of support the human body in a certain way, function. And vase is certainly, well, if it is a member of the furniture category, like you say, it's really a bad one. Good. So that, okay, I'll go with the vase. My example would be carpet. Is carpet a member of category furniture? Well, okay. Park. It doesn't have legs, right? And its flat surface is not rigid, right? If you lift the rug, it's going to be, soft. So is furniture what decorates your house? If that's your one of your defining features, five. One of your defining features, then Leroy's example of vase and Parker's example saying that the carpet, yes, would be, yeah, it would be furniture. So, but for this mm, horizontal relationship in the Aristotelian view, there is no doubt. You either the triangle or you not. You either a fish or you not. You see what I mean? So there is nothing like peripheral member of a category. So you would say, taking the category of furniture, a chair, a table, and a carpet and the vase are equally good representatives. But we know that that's not really the case, right? So we're already building our case that there are certain problems with this classical view with definitions and defining features. Okay, and finally, homogeneity. That's what I already started saying, that all members of the categories are equally good. The equally good representatives. So give me a best category, best member of the category furniture, I'll say vase. And that should be okay. It should be fine. A vase should be as good as table if we understand furniture as what decorates houses. Mm-hmm. Because all of these, if the main defining feature is to serve the house in a capacity of for you to sit down or lean on or put something on, then vases should be as good. So these are the three properties, not even properties, that's not the right way because it will get you confused. Three ways of thinking about how categories are organized. So vertical organization, horizontal, and homogeneity. So if we find problems with these three organizational principles, then we find problems with classical view of categorization. And that's exactly the case. But let's make sure that we practice just a little bit. Okay, so we'll try to define a category. Well, I think I have 3 examples for you guys. So I'm going to show you one category. It's going to be a superordinate, right? Top level. And I'm asking you to come up with features. It's going to be more 1 or 2 at the most. Okay? So we are trying to apply the proper set approach to categorization now. So let me see if I can make it more clear to you. Okay, so my first category is going to be weapons. My second category is going to be beverages. And the third one is going to be vehicles. So in your notebooks, or whatever you have in front of you, write the defining features of each of these categories. Like I said, it could be 1 or 2. So think of weapons. What makes a weapon a weapon? What are the defining features? Remember, these are the ones that have to be singly necessary. That is, every single member of that category has to have it. And then it has to be jointly sufficient that the each member of that category has to possess all of them. So let's say you will need at least 2 or maybe even more, or just 1. Okay, handheld. Well, Karen, I mean, I can hold an axe, right? Or I can hold well, axe may not be a good example. I can hold an apple, right? So cause bodily harm, could deal damage. Okay, okay, good, good. Uh-huh. Can use to harm someone. Okay, good. Let's think about beverages now. What would be the defining features for beverages? Liquid. Okay, is that enough? Can somebody suggest another defining feature for liquids for has a taste? Okay, interesting. Good. Okay, let's do vehicles. What would be the defining features for vehicles? That are not harmful to the human body. Yes, Parker, excellent. That's a very good point. Let's do vehicles. Transit. What else? Transportation, transit. Okay, similar, right? Anything else that we could add to vehicles? Being able to get inside of it. Okay, good. Perfect. So let's start with the weapons. I'm going to show you a few members of this category, and you should apply the definition. The definition for the weapons was, let's come back, cause bodily harm, cause bodily harm to someone. Okay, so let's go to weapons. Okay, brick. Does brick meet this defining feature? Does it have an ability to cause harm to someone? Okay, excellent. So brick is a weapon, although its original function is different from being a brick, from being a weapon. How about next one? Chain. Is chain a weapon? Yep, right, because it can cause bodily harm. Okay, here is my bad example. Why not a sponge? You can use a sponge and force it into somebody's throat and stop the person from breathing, right? But we don't think of sponge as a weapon because it doesn't meet the defining feature originally meant for weapons. You have to be rigid or sharp, like brick is rigid and chain is sharp, right? Heavy. Good. So our definition can cause bodily harm. Maybe will have to be modified if we think about sponge as a think about pillow. I mean, there are numerous cases in the Russian history. I don't know about the American one. One of the Russian czars, Paul the First, that's right, was actually suffocated because his guards ran into his bedroom and used pillows to put it over his mouth, and he suffocated. So a pillow can be used as a weapon, right, to kill a czar. Good. Let's look at the beverages. Water. Is it a liquid? Yes. Right. Then shouldn't all items be considered weapons? Yes, Amr. That's the whole point. That's the whole point. That definitions as proper sets are deficient. So what did we have for liquid? Nutrition. Okay. Does water have nutrition? Yeah, it kind of supports living organism. So that's good. How about tomato juice? Right? It's a liquid. Yeah, it has nutritional value. Perfect. Now comes Parker's feature, which is very important. Motor oil. It's liquid, right? Uh, well, it has taste, I assume, but it's not nutritious and it's not meant to be consumed. So we're not going to call it a beverage. But again, I use wonderful examples from my personal history. In the days of Gorbachev, who was the first Russian president in the 1980s, there was this very strong and severe prohibition. That is, you could not get any liquor. And for Russians who drink vodka like water, it was a big deal. So a lot of Russian men started drinking um, uh, fragrances and perfumes, that kind of stuff. And that's just horrible. It smells nicely, but it's not something that you would think of being a beverage. But they drank them. All right. Our third example was vehicles. Bus, yes, a good example. Transportation. How about bicycle? That's, yeah, reasonably good, right? You can get kind of insight on the bike, right? How about this? An elevator. Is an elevator a vehicle? It is a sort of means of transportation. Perhaps we think of a vehicle, something that has a chassis, wheels, or I don't know, maybe skis, and the elevator doesn't have that. So it's not going to be a good example of vehicles. So, and Amar was saying, hey, look, don't you think that everything could be a weapon? Absolutely. And that's the whole point. If we just use the logical approach of proper sets, we're going to be in trouble very quickly. It works well for math, but it doesn't work well for real life. So here is the Aristotelian algorithm. So determining defining features. This is what you just did. You said that beverage is something that's liquid, nutritious, can be consumed with, by a human. And then you're going to take an object, in this case, tomato juice, and you say, perceptually, does it look like a liquid? Yeah. Do we know that juices are good for you? Yeah, we have that knowledge. OJ, apple juice, whatever. And if it matches these features, then assign the object to this category. So we say, yeah, tomato juice is a member of category beverages. But motor oil is not going to get us through this. Therefore, motor oil is not going to be classified as one. Or my example of perfumes that Russian alcoholics drank in the 1980s would violate this, because in our memory, we know you're not supposed to drink perfumes. You're supposed to sort of apply them to your body, right? And that would force us to include perfumes that are based on, obviously, on alcohol into the category of beverages. But that's wrong. We know that we shouldn't be doing that. Okay, one other little example and then take a break, maybe. Okay, to do it quite as quickly as possible, let's see. We'll just go one by one. I'm showing you 19 objects. Let me go back for a second, Aristotelian algorithm. So think of what this category is, what are the defining features, and then try to categorize each of the 19 objects, whether they belong to this category or not, and what would be the name. All right, so Leroy, you're going to get the easiest one. What's your name for object number 1? Cup. Good. Ari, for object number 2. No, I'm sorry. Ari, object number 2. Wider cup. Parker, object number 3. Another wider cup. Oh, okay. Can you guys be a bit more creative? Amr, object number 4. Bowl. Okay. Noor, object number 5. Mug. Karen, object number 6. Okay. Leroy, object number 7. Wine glass. Leroy, number 7. Whole cup. Okay. Ari, number 8. Deep cup. Parker, number 9. Vase. Yeah, except it has a little handle. Okay. Ummer, number 10. Measuring glass. Okay. Noor, 11. Bucket of water. Karen, number 12. All right, Leroy, back to you. 13. Not sure. Okay. Leroy, 13. Ari, 14. Again, measuring cup. Okay. Parker, 15. coffee cup. Okay. Number 16. A really tall cup. Okay, Noor 17. Wine cup. Okay. And Karen, number 18. And Leroy, back to you, number 19. Teacup. Hmm. This is weirdly hard. That sure is. Well, that's the whole idea, right? So presumably, think about homogeneity of the proper sets. All of those are united by, okay, they are vessels, right? They have some kind of a, they're like a container. They all meant for beverages to be consumed. They all have handles. But once you get a shape like 19 and 18, you start getting a little dubious. Or think about 4. One of you called it a ball. Yeah, it looks like a ball, except it has a handle. So all these things make it really difficult to use the Aristotelian algorithm by first defining the features and then categorizing objects based on the visual properties and the function. Goody. Looks like piece of cake. That's right. All right, it's 11:26. Let's have a break, let's say until 11:32. Okay? If I can type today. Until 11:32. Okay, let's continue. We have already started to identify some problems with this classical view of categorization. Yeah. So these are at least five um, problems, might be more, that are very vivid in terms of telling us we definitely are not using sort of rational approach to categorization. So let's just name them. So we have something that we call disjunctive categories. And remember that jointly sufficient means that um, any object has to have all the properties, all the defining features to be a member of the category. And here we will have categories that are defined by not having a property. Sometimes we're not sure whether a particular object is the member of the category, like vase or carpet. Are they members of the category furniture? We also have issues with specifying defining features. We saw some examples already with the weapons and beverages, and a couple of others, in particular variations in typicality, which is what will lead us to the prototype theory. So let's start with the disjunctive categories as the first problem. Again, some of the members have to be defined by the absence of category, or you would have two members that overlap in some features, but then not others. Again, this is completely prohibited by the classical view. A classical view, you have to be singly necessary and jointly sufficient in terms of defining features. Okay, so the example for those of you who are into sports, in particular in baseball, would be an example of a strike in baseball. Does anybody know what makes a strike in baseball? Home run. um, well, a strike is you have a pitcher, and the pitcher is throwing the baseball, and then there is a person with a bat, right, who swings, a swinger. Yes, no? Nobody knows what a strike is in baseball? Hmm. I'm not a big fan of baseball, but so here is these are the features of a strike. Yeah, the potential to be hit, right. A pitcher throws a pitch and the batter swings and misses. That's a strike. Okay? Hitting the ball in the foul zone, and the foul zone is identified in a certain way, except for the third foul. Throwing the ball in the foul zone between the shoulders and the knees of the batter. It's all these features. But look at the last one. The umpire calls it a strike. Now, that cannot be defined as a feature, right? This is sort of arbitrary. We creators, humans, creators of this baseball sports activity, have umpires, and umpires have the power of calling something a strike. Okay, so it's a completely strange way of thinking of defining features. Another good example is jazz. Does anybody like jazz among you guys? Yeah, it's it's an acquired taste. So there are two types of jazz. There is swing and there is not really. There's swing and there is blues. And they're very different. But both of them are united under this umbrella of jazz. And a lot of jazz is, well, one of the defining features would be improvisation. So one of the members of the jazz band starts, playing. a particular riff or melody. Everybody else has to sort of chime in, some, well, without any preparation. But we do have improvisation in other musical styles. Okay, so these two are examples of the disjunctive categories that are defined by not having something, or having something that's completely arbitrary, like the umpire calling a strike a strike. So, and that's a very common situation in with real life categories. Let's look at the unclear category membership, right? We already looked at the example of vase and carpet, right? Rug is just like a carpet. Is it an article of furniture? Nah. If we define furniture as everything that decorates the house and serves, supports human functioning, yeah, maybe it is. Another good example of that, like a vase, I just thought about it, would be like an ashtray. Well, and people have ashtrays even if they don't smoke. Is that a piece of furniture? You don't sit on it. You don't lean on it. You don't put stuff on it. Well, you do put ash. Is that? It's not clear at all. If it is, it's a very peripheral member, which again shouldn't be the case when we talk about jointly sufficient. Is my favorite example, is tomato a fruit or a vegetable? What do you guys think? What would be the defining features of tomato category? Okay, I always thought it was a vegetable. Okay, so Amr, you thought of that because it functions as a vegetable, right? You slice it in your salad and you make a gazpacho out of it or whatever. You, what do you do with fruit? If we are thinking about the way we eat stuff, we can add the fruit to our cereal, right? And like strawberries to whatever cereal and milk. We won't think of uh, tomato as something that you would add to your bowl of cereal, or something you would have for dessert, which is what we do with fruit. So functionally speaking, right, Amr, you are completely right. It functions as the vegetable, but botanically speaking, it is a fruit. Okay, so here, right, we would, if we were using defining sets as proper sets in the form of Aristotelian algorithm, we should define tomato as a fruit because of the seeds and the way it grows on the vine and all of that. Not in trees, but on little plants. Well, not so little, but plants, not trees. I'll come back to that in a second. I just want to show you the idea. So here's what happened with tomato, and I think that's a hilarious story. There was a customs, a tariff act of 1883, where yes, vines, exactly, where any vegetable that was imported into the United States was taxed, and it was 10%. So it was pretty high tax. So uh, the controller, the customs officer in the port of New York, wanted to collect tax from tomatoes. So this guy unilaterally in 1883 declared tomato to be a vegetable. And at this time, check this out. I thought it was very hilarious that there was an international tomato cartel. Well, these days we have drug cartels. In those days, there was a tomato cartel. They went to the Supreme Court. They sued the customs collector of the Port of New York by saying that they cannot tax tomatoes because tomatoes are not vegetables, they're fruit. Okay? So now we're back into this gray area. Well, what do you do with it? Do you treat it as a vegetable or do you treat it as a fruit? Again, botanically, we know it's a fruit. So Justice Horace Gray, who was representing the Supreme Court, made this decision. Actually, the name is Nix versus Hedden. This is what he said. He said, botanically speaking, tomatoes are the fruit of the vine, just as are cucumbers, squashes, beans, and peas. But in the common language of the people, Amr, you're with them, all are vegetables, and these vegetables usually served at dinner, in, with, or after the soup, fish, or meat, which constitutes the principal part of the repast, and not like fruits, generally as dessert. So, botanically speaking, a fruit, the way it functions in our society, is a vegetable. So they upheld the tax on tomatoes 10 years after the whole thing started. I think it's very hilarious that we can go against them, science, in our categorization, because that's how we think of tomatoes. We think of them as vegetables. Okay, um, those features, right? The defining features. Triangles and quadrilaterals and birds and fish are easy, but there are many, many cases where it's not easy at all. The most famous case, perhaps, is the case of Ludwig Wittgenstein, which is in your textbook on page 249. He's a famous German Swiss philosopher. There he is, Ludwig Wittgenstein. Okay. His example, because he actually looked a lot of the categorization by definition, as cucumbers are fruit too. Yes, botanically speaking, again. Well, you'd be surprised how many funny things there are in botany and other places. So he defined this example as game, right? It's a competitive physical or mental activity engaged in for amusement. And he said, well, look, if you're playing solitaire, how many of you guys have solitaire on your phone? And in days when we would have to wait for buses, people are standing there playing. Okay, there is no competition. I mean, you're competing against yourself. If you play this sort of ancient children's game called The Ring Around the Rosie, um, there is no winner. And think about professional football, amusement, anything but amusement. That's hard work. So it's not even that we're talking about something as complex as a definition of justice, but it's a definition of something that we all intuitively know how to use, like a game. And that's a actually Wittgenstein is also the guy, if you remember from the language acquisition week last week, right? It was the guy who came up with the Gavagai problem. And the Gavagai problem was showing people a blue rabbit and imagining that you are in an unknown land and you have a local who doesn't speak English, and the local points to that blue rabbit. It's either a billboard in the modern society, or think of actually a blue rabbit sort of jumping in the field and saying Gavagai. I mean, what does it mean? Does it mean a rabbit? Does it mean long ears? Does it mean it's jumping? Does it mean, oh, look how cute? Right? It's the same philosopher, Ludwig Wittgenstein. His stuff is extremely fascinating, but it's philosophy, so it's not an easy read. Here is my second favorite example of that. And I mean, we won't have much time to talk about it, but you could use that for your activities if you want. It's a concept of a planet, right? If you have ever taken astronomy, and a lot of people did, you would know that there is definition. Here is a classical definition. It's a celestial body, okay, that revolves around a star and does not itself revolve around another celestial body. That's why the moon is not a planet, because it revolves around the Earth, which is a planet. Okay, so that's the definition. And according to this definition, our solar system has 9 planets, right? So we have Venus, Mars, Earth. No, we have Venus, Mercury, Earth, Mars, my very earnest mother, Saturn, uh, what was it after Saturn? Neptune. The last one is Pluto, okay? The Pluto was discovered in 1930, which is almost 100 years ago, and its distance from the sun is about 4 billion miles. It's a very long way. Jupiter, that's what I forgot. Okay, so Mars, Saturn, Jupiter, Neptune, Pluto. Okay, so by this definition, these are all celestial bodies. They all revolve around the star, which is the sun, and none of their satellites are planets. So Saturn has its own moons, Jupiter has its own moons, and so on, but they're not planets. So that was what we knew for 100 years. What about meteors and comets? Well, we know they're not planets because they don't meet the definition, that these defining features are not something that would be applicable to, let's say, meteors or comet. Okay, but there are some new celestial objects that have been discovered lately that have some of the properties of planets. And then Pluto, poor thing, has something that does not quite make it a planet. So the International Astronomical Union has decided to take Pluto as a case against planets. All right, so think of Pluto. There it is. Oh, Uranus. Let's get my color. Let's get a different color. All right. So Pluto, right, is here, and its orbit, that the way he sort of revolves in the universe, is very idiosyncratic. Its orbit is not exactly the way the planet tilts, and all of that is not exactly the way it should be. And this conglomeration of objects is called Kuiper belt. Here's Kuiper belt. And supposedly, a lot of objects, and they're called KBO, Kuiper belt objects, are just like Pluto. That is, their volume, their mass, is within 2 standard deviations of Pluto. Pluto is also all ice. So why is it that Pluto is a planet, right? And then a bunch of objects that are in Kuiper belt are not planets. In terms of size, some of them are just like Pluto. So the idea was that we will have to change the definition of a planet in such a way that either to include, for example, these objects, Sirius and Xena. Xena is actually twice the distance. So Pluto is about 4 billion miles, and Xena is about 7 billion miles. So Xena perhaps must be a planet. Or if we declassify Pluto and classify it with Xena, then we need another definition of a planet. And that's what this International Astronomical Union has been fighting with for the past 20 years. I think it started in about 2002 and 2003 when they started questioning Pluto as a planet. All the others, Jupiter, Saturn, Uranus, and Neptune, are not a problem. They're huge, huge planets. The orbits are more or less appropriate, and so on. But Pluto, unfortunately, was singled out. So why non-Ceres and Xena planets? So the definition here is some of the masses. So you can see this. This is Xena. Okay, that's, I don't know, almost like, in fact, it's a little bigger than Pluto, right? Why isn't it a planet? So the solution was to declassify Pluto as a planet. So instead of having 9, we know now at that point we had 8, because here's the new definition. They have to orbit the sun. Okay, they have to have enough gravity to be spherical in shape. Okay, well, Pluto and Xena both sort of meet that. But here is this third defining feature, that the orbit should be cleared of the space junk. But remember that Xena is in a Kuiper belt. There's tons and tons and tons of other things around it. Okay, so in that sense, Xena is not a planet. But Pluto becomes also an issue because it's not enough gravity, its orbit is eccentric, and so on. So the solution was to declassify at that point Pluto as a planet and create a new definition called dwarf planets, and then make Pluto and Ceres and Xena dwarf planets. But the funny thing is, if you remember the basic level categories and superordinate and subordinate, dwarf planet should be subordinate, right? Then you need to add features, and that's not the case. Dwarf planets become sort of hierarchically above the basic definition of a planet. So it's a total mess. And this International Astronomical Union continues to fight, but many astronomers do not recognize the fact that Pluto has been declassified and continue to think of Pluto as a planet. Finally, there's one more. We have this imperfect nesting. So again, if you think about superordinate, basic, subordinate hierarchical organization, then the idea is if you give somebody, a participant, a task where they have to verify a sentence, the distance that you travel from the object that you are classifying to the level where you need to do your verification should depend on the distance between the object and hierarchical organization. So the higher that node is, the longer it should take you to say yes or no. So here's an example. Let's say somebody says, when you hear the sentence, say yes if it is true, it's a true fact, or no if it's not a true fact. So true, false judgment. So chicken is a bird. Well, yes, right? Chicken is a bird. Now, what about B? Chicken is an animal. Well, so if you think about chicken, bird, animal. So getting to the animal level should take longer. Think about mental imagery that we discussed a couple of weeks ago. While getting to the bird should be faster. So the prediction is that the reaction time is faster in A than in B. In reality, it's actually the other way around in experiments. So people are fast in classifying chicken as an animal than as a bird. That's okay. Okay, you would say, well, it's just one example. But if you continue to look at the results of these experiments that use sentence verification task, if you give somebody a sparrow as a bird versus sparrow as an animal, if C and D is just like an A and B, then D should be faster than C, just like B is faster than A. But here it's the other way around. So chicken as a bird is slow, chicken as an animal is fast. Here sparrow as a bird is fast, and sparrow as an animal is slow. So they're not nested perfectly. That's why it's called the imperfect nesting. It looks like your verification and the levels depends on a particular member of the category, because chicken is not a very good representative of the category bird, while sparrow is very good. And the same comes with pigs and dogs. There are many examples of sentence verification tasks that go, in these examples, go against this proper sets. And these are some of the results. So you can see. So sparrow is classified as bird versus chicken classified as mammal, and the other way around. So this is the 1973 sentence verification experiments. Okay, let's do this because we need that in the remaining 8 minutes, because we need that for our lab 3. One of the earlier alternatives to the classical view of categorization as proper sets is what we call semantic networks. So instead of thinking of a sort of this defining features approach, we will think about networks. And we will assume that most of our categories, in fact, are represented in the mind. A brain is a separate story, as nets. How will it look like? Well, the story that we need to start with is by Collins and Quillian of 1969, where they introduced a bunch of terminology. So they have a node, and a node is a concept or a category. So let's use the word category the way we did that. And the categories are linked with arrows. So you think about drawing this. You would have the nodes, and then there will be arrows that connect them among each other. And presumably this is how we think about these concepts in our mind. And this is our semantic knowledge. And it's also the way we think about vocabulary in language. So that's the famous semantic network of Collins and Quillian. Okay, so the green level here, right, is our basic category level that we already know, basic. The one that's the easiest to come up with, the one that the children start acquiring language with, and so on. So it's basic. Again, for the proper sets view, that's a problem because everything should be the same. The orange and above is going to be our super ordinate level. Okay, it's above the basic. And the way we would do it in the proper sets is by losing features. And the blue level is going to be a subordinate, right? And again, in the proper view, proper set view, we would add features here. So now the actual words are categories. So we have a category of fish, a category of bird, a flower, and tree. And then we have those arrows that give us the characteristics of these categories. So a flower, and the function, they call it, a function is a. So a flower is a plant. And here it has. So flower has leaves. Flower has petals. Flower is pretty. And the representations, again going up, would be daisy is a flower. Rose is a flower. And characteristics are rose is red and daisy is yellow. You see how it works, right? So it becomes a network of semantic features. In a way, a little bit similar to the proper sets, but it's not defining features. That's the difference. They don't have to be singly necessary and jointly sufficient. So you can think of any category using these nodes and arrows. And the reason why they're good, because they allow us to do all kinds of natural things without worrying about defining features. I'm not going to go into these details. And you can now think of a sentence verification task, okay, by saying, here, let me get it again. if you have to verify a sentence, canary is a bird, that should be faster than verifying a sentence, canary is an animal, because this is 2 steps. Mental imagery again, and this is 1 step. So the distance between the nodes predicts how long it takes to retrieve the information about concepts. Now, this becomes important for the lexical decision task, which we will finish with now. Oops, let's get rid of the drawings. Let me go right into that. Oops. Because of what they call spreading activation, that is, think about neurons, the way the neuronal impulse traverses between neurons, among neurons. So lexical decision task, this is what you're doing for lab 3, is when a participant is viewing a letter string, actually viewing 2 letter strings, one on top of the other. Many of you have already finished the experiment, so you know what it is. And one of them is in caps, and your job is to identify whether whether the string in caps is a word of English. Obviously, there are fillers that are non-words. And the idea is that if you think of these words as being related, they are in the network, then one of them will facilitate the recognition of the other. And that's what Meyer, misspelled, and Schranewald found. They found that if 2 letter strings are related, then the reaction time is faster. Well, because they activate, one of them activates the other. And if they're not related, then there is no facilitation. So there will be the baseline reaction time. So I'm asking you to use the activity number 12.1 and do read and answer a bunch of very applied questions based on the idea of spreading activation. Okay, thank you guys for attending, and the class is over, and I'll see you on Thursday.
Professor?
Yep.
So
Go ahead, Noor.
So last week I did activities, and like I think 8 activities for that week and the week prior, but you only gave me 4 points.
So how many activities did you do?
I did, for that week I did 4, and then for the week prior I did 4, so it would be 8.
I think sometimes the way the blogs are created, they don't quite coincide with the week. So what I need you to do, Noor, is to go to your blog and tell me how many activities in total do you have by now, because the blogs will show you these activities. But remember, there are 2 additional things that you need to remember from the beginning. First of all, if you have any articles, and articles are worth 2 points, not 1.
Mm-hmm.
Yeah, Summer. See you Thursday. And then in the beginning, because I was checking for correctness, it's possible that you could have lost, take Elroy, half a point at some point. So what I need you to do is to email me and say, blogs show, I don't know, 28 posts, right? Out of those, 8 are articles, which means that's 16 points. Maybe minus 1 or 2 in the beginning if you didn't do the variables correctly. And then that number should be, so sometimes the way I put it in my Excel sheet where I keep track of all the work is that I put a bunch of points in 1 week, although they may be spread over 2 weeks, because I can't always tell which, not everybody marks the activities or the week. It's hard for me to put those points exactly where they were published by you. So what matters, Noor, is that you should have as many points as you have accumulated them by now, regardless of the week. You see what I mean?
Yeah.
Okay, so do
So
that. Go.
yeah, I just checked and it says that I had like 26
Mm-hmm.
blogs.
Okay, how many of those are 2-point activities?
Only one of them, I think.
All right, so you see what I mean? I need you, I'm gonna look at my my Excel sheet, but I may not be able to tell you exactly because that's why I'm asking you to do it for me.
Mhm.
All right, so I'm seeing, okay, I can sum them up. Sum them up. Okay, my number is 22.
Mhm. Yeah, but
So,
yeah.
it,
Um.
and it is possible. So there is only 1 week for which my Excel doesn't have anything for you, which is the week of September 28th. But again, remember that these activities actually go forward, not backward. So
Oh.
if you have 28, so for example, I can tell you that the week before, the 21st of September, you only got 2.5 points, which means you lost probably half a point somewhere. And then the week of October 5th, also 2.5. So let's say if I were to add this, that would still give you only 23 out of 28. So we need to, you need to go and give me a little breakdown, okay?
Yeah.
Which ones are, so you say only one is
So yeah. So what
the
happened
article.
is
Mm-hmm.
that I think you check the articles, you check the responses on Monday, but I actually
Yes,
submitted them Tuesday.
but the
So.
way it works for me is when I go to Blackboard, it shows me all the new postings. So if I did not grade something, it will appear as a new blog and I will grade it next week, but it may not be in the same week where you posted it. See, it's just because it's open until today. It's open until 10 a.m. Tuesday. And if I do grading on Monday in the morning, let's say, and you post something on Monday night, I will only grade it next week.
Yeah, but I already posted these like more than like a week and a half ago. And I
Okay,
checked
well,
my grade this Monday and I saw that you only added 4 points and I was confused. I was like, wait, did she not see the other 4 blogs that I did? I can send you all of the blogs. I already have them on my Google Docs.
okay. All right, then what you should do is send them to me with the breakdown for the weeks. All
Mm-hmm.
right, so at this point, I have the way this is broken down for me is 10 blogs
Mm-hmm.
because this is, so September 7th, the first week of the week of August and the first week of September did not count. There was nothing there. So my first grade, and that you have it, let's see, yeah, you have one. So this is, you can write down what I have and then compare and tell me what's not the same.
Mm-hmm.
So September 7th, 1. September 14th, 2. These are the points that I have for you. September 21st, 2.5. September 28th, nothing. October 5th, 2.5. October 12th, 2. October 19th, 4. October 26th, 4. November 2nd, 4.
Mm-hmm.
And I haven't graded. If you posted something last night, I did not grade it yet. So on my Blackboard, it will look like new, which means if you posted 4 new entries, you will get the 4 points on the 23rd of November. See what I mean?
Yeah.
So do the breakdown and send me all your posts with the dates
Mm-hmm.
for these weeks, and then I will be able to check it against what I see in the Blackboard. Okay?
Yeah. And even like the 4 points that you graded, it should have been 5 points.